I have done until question 6 for you, correct? Everything is on the full scan. I didn't give any notebook work. Okay, I've done until question 6 and I told you to do question 7 and 8. Is it correct? Okay, I'll read the number. If there's problem, eraser. 7. Okay, 8. No problem, huh? Okay, good. I will collect it later. Okay. Alright. Now, can we now turn to page 185? I'm going to tell you more about similarity, enlargement, and scale drawing. Okay? Now, similarity is also used in real life. For example, I told you before, you know the Malayan souvenir is actually a scale down of the actual Malayan. Nobody's going to bring the whole Malayan back to the country as a souvenir, as West Coast. Do you understand? Okay. And when we go and buy, let's say, a flat or condo, there will be a floor plan, right? But the floor plan is not as big as the floor itself. Okay, that will be West Coast as well. Alright? Then the world map. The world map is also a scale down of the whole world. Okay, but you must know to what ratio is it scaled down. Okay, and if let's say we are magnifying something, we are enlarging something, we must also know to what scale we update it. Understand? Okay. Alright, now let's take a look at page 185. Similarity and enlargement. Okay, now let's go through the page first. In the previous section, we have learned that two figures are similar if they have exactly the same shape but not necessarily the same size. Their dimensions are in proportion. This is what we have done, right? Okay, next. Look at figure 7.10a. A letter S may appear small on a book. The person uses a hand lens, that means a magnifying glass, and enlarges the letter for a clearer view. Figure 7.10b, the letter would appear larger. Okay? Now, they write at the side there. The scale factor is 1.5. That means it is 1.5 times bigger than the original. Understand? Now, I want to talk about scale factor first. If the scale factor is 1, it will be exactly the same size. Because we never enlarge anything, it's still 1. Do you agree? Okay, now, if the scale factor is more than 1, how do you think it will happen? It will be an enlargement. Agree? It will be an enlargement. Okay, now, then we go on to the next one. What if the scale factor is less than 1? It will be a reduction. It means the final figure and the original figure, the final figure will be smaller. So this is how we look at scale factors. Everybody okay? And we always compare to what? The original figure. Understand? The original figure. That is something that students always get confused with. The one at the bottom must be the original figure. Okay? Alright, so that's good. Let's take a look now. After the diagram, page 185, the larger letter is an enlargement of the original letter S. We said that the two letters are similar to each other. The corresponding lengths of the letters are in proportion. The ratio of the length of the enlarged letter to the corresponding length of the original letter is called the scale factor. Is that clear? That's called the scale factor. Okay. Now, another example is enlargement of a photograph on a screen using a visualizer. Okay, the photograph and its projected image are similar. Okay, then they give you the dimensions there. I will talk about this later when I do the examples. But in the first place, are you clear with this? Everybody okay? Okay? Okay. Now, next one. Let's look at example 9. Okay, I'm going to go because there are few categories in this particular section, so I have to go a bit slower. Now, in the figure, triangle A prime, B prime, C prime is an enlargement of triangle ABC with a scale factor of 2. Given that AB is 4 cm and AC is 5 cm, find the length of A prime, B prime, and A prime, C prime. Okay. draw you the figure. Okay. What did they tell you? What is the scale factor? Focus. Yes. Scale factor is 2, right? That means the final one must be bigger than the original one. Okay, now, if the scale factor is 2, that means A prime B prime over 4 must be correct. That means this one, okay, I don't put 4 first, I put here. Must be correct. Agreed. The corresponding line must be 2, right? Then, of course, A prime B prime will be what? AB times 2, correct? Now, what's AB? 4. Correct? 4 times 2. 8 cm. Now, of course, you can just do 4 times 2, 8 straight away. It doesn't matter. Okay? Because it's quite obvious here. But the thing is, what I want to stress is this. Now, can you see that I took the image? Image is the final one. Over the original, and it's 2. Can you see now? It's always like that. Sometimes it's not so clear cut. Everybody clear? It's always image over what? Original. That is the scale factor. Everybody understand? Okay, now can you see that? Actually it's from here that I get A prime B prime is 8 times 2. It's actually from here, this is the basis. It's the fundamental statement. Are you all okay? Alright, now then they want to find A prime C prime. So A prime C prime is actually over what? Original is AC, that is 2, right? But what is AC? 5. So A prime C prime over 5 is 2. So A prime C prime is actually 10. Can see it? Then you ask me again, Joe, can I just take 4 times 2 and 5 times 2? The answer is yes. But I want to show you where the fundamental statement is. Everybody clear now? Everybody clear now? So if you see scale factor 2 straight away times 2 is okay. Now that's the danger. If I give you 10 cm here, and I want you to find the original, then you have to divide by 2. Can you see? The thing can change. Understand? Not just from the original to the image. It can be from the image to the original. Then you must know the factor is what. Understand? That's why, if you have this fundamental statement, you don't have to worry. It's very clear. Just do a cross multiplication, you can get the correct answers. It's always image over what? Original. Everybody clear? Can or not? Because it's always giving students trouble. Okay, now, next, I'm going on to page 187. Similarity and scale drawing. Are you okay with the scale factor first? What's very important? Okay. In our daily activities, we sometimes need to enlarge or reduce pictures or drawings of actual objects. For example, if we wish to draw a plan of a badminton court in order to explain the rules of the game, you need to make a much smaller drawing on paper or on a whiteboard. If we wish to draw a diagram of the apparatus used for the distillation of water, we can enlarge the diagram on the screen using a visualizer. Okay, now, figure 7.12 shows the floor plan of a house. It is similar to the actual floor of the house. Okay, now can you see that all these are in cm? Okay, they cannot draw in meters, then must bring you the whole house and see better. Okay, now let's take a look. The dimensions of the plans are proportional to the actual dimensions of the house. Figure 7.12 has been drawn to a scale of what? What did they say? 1 cm to 2 meters. Now, when people tell you 1 cm to 2 meters, what does it mean? It means 1 cm on the drawing is 2 meters on the ground. Understand? Okay. Now let's take a look. That is 1 cm on the plans represents 2 meters on the actual ground. From figure 7.12 we have. Now look at the length of the living room. Can you see it's 3.5 cm? Can you see? So I need to multiply by 2, right? Then the actual length of the living room is what? 7 meters. Everybody okay? Now I don't have to explain the rest. It's quite clear cut. Okay. You just take, convert it to the actual, and then you multiply for the area as well, and so on. I don't have to go through this because it's just a down version. Everybody okay so far? Okay, so first thing I talk about scale factor. Then I talk about scale down, like 1 cm represent how many meters in real life. Everybody okay? Okay, Alright, next, we look at scale drawings. Let's take a look at scale drawings. The next page, 188. Let us see one example on how scale drawings can help us to find information of the actual object it represents, and another example on how you can use graph paper to draw a scale diagram. Okay, now, next, example 10. I'm going to go through this. Find the scale of a drawing by measurements. The diagram shows a scale drawing of an apartment. By measuring the scale drawing, okay, find its scale. And 2, find the actual length L in meters of the apartment. Okay. Okay. All of you use your ruler now. You measure. This is the thing. Now, I'm not going to draw the whole plan. It's just a rectangle, right? Okay. What did it say here? 9600 and N. Correct. Now, actually, what they said down here are these are the actual length. Okay. Now, I want everyone to look up. Some people don't even know how to convert. May I know 1 meter how many cm? 100. 1 cm how many mm? 10. 10. Okay, now look here. This one means is 960 cm, right? Okay, now I divide by 10, right? Then how many meters? 9.6 meters, okay? 9.6 meters. Actually, this apartment is quite big. You know 9.6 is actually quite big. Do you understand? Okay. All of you measure from here to here, how many cm? Use your ruler, don't look at it. Your eyes are not vertical calipers, no? Use your ruler, measure that length there. What do you get? Tell me in cm. 6 cm. Okay. That means 6 cm represent 960 cm. Okay? Agree? Okay, now, why did I purposely from cm? Because I can use a scale in the ratio form later. Okay, that means 6 is to 960, right? Once I have the same unit, I can drop the units. Okay, so if I change to lower skirt, what will it be? 1 is to 1 is to 160.
160.
Oh, 160. Okay. Now, can you see that from here I can get this ratio? Okay, now 1 is to 160. If people give you this ratio as the scale, it means 1 cm represent 160 cm. All the units must be the same. Or 1 meter represent 160 meter. Also can, but nobody will get a 1 meter paper to draw the map. That's very stupid. Understand? Usually we don't have this, but you make sure it is in this type of ratio. This is cm, this is cm. You understand? It's understood. Nobody will tell you. I'm telling you now. Everybody clear? So you look at the solution on page 188. By measuring the vertical width, it represents 9600 mm, we get 60 mm. Actually, we use cm, it doesn't matter. 60 mm is actually 6 cm, right? Can you see? Okay, so the scale is 60 is to 9600, which is 1 is to 160. Everybody clear? Everybody clear? Clear, huh? Okay, now let's look at part 2. Find the actual length L in meters of the apartment. Okay? Now, let's say I work with this. One is to 160. That means 1 cm represent 160 cm. Agree? Yes, they want it in meters. So 160 cm is what? 1.6 meters, right? That means 1 cm on the map is 1.6 meter on the ground. Got it? Okay, I want to use a ruler. Measure the length there. What is it on the map? the length here? 16 cm. Is it exact? Okay. So 16 cm. 16 cm will represent. Now, if 1 cm represent 1.6 meter, 16 cm will represent 1.6 times 16 times. Everybody agree? So use your calculator. What is that? 25.6. Very good. 25.6 meters. So in actual fact, the so-called the horizontal length of the apartment is 25.6 meters. Okay? It's quite a big apartment, correct? Can you imagine you go to the track, right? You need a track, I feel like 100 meters. Or can you see it's like 1 quarter? 25. Correct? It's quite big, you know. This is a very rich family. I can only afford a kitchen hole. Okay, where you know some bathroom, you know, you go to some hotels, you go cruise especially, you know those ship, what is it called ship or boat? I don't know what it's called. You know the bathroom is so small, you can't even turn. I think if I am a bit fatter, right, straight away I cannot bathe with it. Because the shower is right, I'll just stand there and the water will just splash on. You can't turn really. And nowadays, right, I'm very upset with the apartments that they are selling because they are getting smaller and smaller. Do you realize? Especially those condo, you wake up only you face your TV already. You know that there's no space to walk. You know that? You wake up, the TV is there. After you sleep, after you the TV is still there. Then when you wake up, you see yourself, the reflection so scary. That kind of situation. Okay, so they're building it very small. Okay, that's why my mom refused to shift because my house is a old estate. It's bigger. Okay, and you know she got a lot of pots and pans, you know those like a lot of things, right? You know those big that they put curry one. You can put one big rooster or whatever inside. The curry, she got so many of them, you know. She said shift to another house, she will not be willing to throw away all her pots and pans. Then I said then you don't shift. Because there's not enough people to see. How to put the pots and pans, you tell me right now. Alright, I think you better donate to the markets, I tell you first. Okay, but never mind. She said she's very tired of shifting, so I'll just stay there for the rest of my life. Okay? Alright, so are you okay with the scale drawing here? Okay, alright, next. Can we turn to example 11? This is the one that's interesting and a lot of students will like it. Okay? Using graph paper, draw a scale diagram of the figure shown with a scale of 1:2. Now, what do you mean by 1:2? That means this is the original. Can you see? This is the one that is on the map. This is the one on the actual ground, right? So 1:2 means the final one must be bigger than the smaller one. This is always the original. This is the final. Everybody clear? Okay, now let's take a look. I don't want you to draw. The diagram is drawn for you. Look at the next page. Okay. Now I just want to look at the bottom of that house drawn. Can you see it's 4 cm on the graph paper? So if I enlarge 2 times, what should it be? 8 cm now. So can you see 8 cm? You just draw accordingly. Now how should be able to do this? I'm quite good with this. So I'm not worried about that. Okay, now if some people were to say, oh, I don't understand how come is like that. That means you see, 1 square here will be 2 squares here, right? Can you see? So 1 cm will be 2 cm over to the other side. Okay, original final. So can you see that you will get an enlarged house on the next page? So there's no need to talk about it. Everybody okay? Now, can you see that there are very tiny concepts in this particular section, but are you okay so far? Okay, good. Next. Okay, this is about construction. I never asked you to make construction set, but I hope you remember construction. Okay, what do you need? What is in your instrument set? Can you tell me? Compass, protractor, ruler, and set square. Okay, you are expected to know how to draw like last time, but I know you forgot already. That was chapter 12 last year. Okay, by the time you remember, that's too late already. But I want to revise some concepts with you. Okay, about constructions. You don't have to construct. I will tell you. Now. Remember I said if I want to have a triangle, let's say this is 8 cm, I'll use a ruler and put down that 8 cm, right? Alright. Now, what if I know the triangle is like that? say to all you do a rough sketch on top. Okay, so A, B is 8 cm. Let's say this is 6 cm, this is 5 cm. Now, can you remember, I asked you to open up the canvas to 6 cm. Alright, then you put that. Put that A right. Then you draw one up, remember? Then how do I get, I forgot to say C. How do I get BC? I'll open to 5 cm and put where? Put at B, then I have another arc right. Alright, then when I join this, this will be my 6 cm, this will be my 5 cm. Okay? That's how we do it. Of course, protractor, we just use protractor like that. One is nothing. Alright, you see that? Okay, let's take a look at this particular example. Example 12. Now I'm not going to do any questions on construction, but I'm just telling you how to construct and to scale. Okay? Alright, now let's take a look at this one. The scale drawing in the space below. Okay? Then after that I'm going to the proper one already because I need to talk about map scale. Map scale is the one that is usually coming out in the O levels. Okay? Now, the scale drawing in the space below shows the positions of the towns A, B, and C. A is due north of B and C is due east of B. Given the angle BAD is 80 degrees and angle BCD is 65 degrees, find and label the position of the town D. Okay, let's do the first part first. That means these two lines are already given to you. No need to redraw. Okay. So I have like that. Okay, they give it to you like that. So we have A, B, and C. Okay. Now, first thing, they say angle BAD is 80 degrees. That means I must put my protractor where? BAD, that means D is somewhere there, right? I must put here and then measure how many degrees? 80. 80 is less than 90, so it will go this way, right? Something like that.
So they want to be like 6.
80 okay? Can you understand what I'm saying? Okay, then what did they say? What else? Angle what? BCD is 65. So you have to put your protractor here, right? 65. So this will be the D, right? Because of the intersection. Everybody clear? So that's the first part. Are you okay here? Are you okay here? Alright, good. Next, let's take a look at the question. A pole P is to be erected equidistant from towns A, B, and C. Okay, A, B, and C. Alright? By constructing perpendicular bisectors, find and label the position of the pole P. Now, last year I explained, but I think you forgot. Never mind. If I have a point A, B here, okay, where will the points that are equidistant to it be? The perpendicular bisector, right? Okay, how to construct perpendicular bisector? I told you to open up the compass to more than half the length. Very good. Here, right? How come I cannot have less than half? The arcs will not intersect. Correct? The arcs will not intersect. More than half, you put one on top, one below. One on top, one below like that, right? So this guy will be the perpendicular bisector. Agree or not? Now, then I want to tell you this. Do you agree that if I have this point is equidistant from these two? If I have a point here, this is also equidistant because it's an isosceles triangle. Any point here will also be equidistant. Agree? It means any point at all on the perpendicular bisector is equidistant from the two points. But now you look at the condition part 2, it's a bit more stringent. A pole P is to be erected equidistant from towns A, B, and C. By constructing perpendicular bisectors, find and label the position of the pole P. Now, it must be equidistant from A and B. That means I must construct a perpendicular bisector of A and B. Alright. So, you can, I told you already, you can turn your paper. You can don't turn the head until you square the head. It doesn't do good. So, you will have something like that. construct, right? Then this will be the, I create it a bit first. Right? I don't do this, I must construct, understand? So this will be the perpendicular bisector of AB, right? So any point on this line will be equidistant from AB, agree? Now how do I find points that is equidistant from BC? I must draw a perpendicular bisector of BC. So I will have to do construction. Maybe here. Out of line. Now, on the red line is equidistance from AB. On the blue line is equidistant from BC. Where's the point that is equidistant from all three? The intersection. Alright, good. So it's this point here, right? So this is where I should put the P, correct? Everybody clear so far? Okay, so let's take a look. It's already done. Alright, next. The actual distance of AB is 60 kilometers. By measuring the scale, drawing, find its scale. That means this AB is actually 60 kilometers. Okay, I want to use a ruler. Measure AB for me. How many cm? 6. So that means 6 cm represents 60 kilometers, right? That means 1 cm will represent, yes, very good, 10 kilometers. That's one way to represent the scale. Okay, but what if I want to use the ratio 1 to something? That means this one 10 kilometers will be how many cm? Oh, sorry, how many meters first? 1 0 plus 3 0, right? 0 0 0 meters, right? How to become cm? And how to become 0? So, you'll be like that, right? 1 million cm, right? So if I want to use the ratio for, you'll be like that, right? You understand? But if you never specify this one will do. If you specify, you must do this one. Depending on the question itself. Okay, everybody clear so far? Okay, alright, now next. Hence, find the actual distance from D to the pole P. Now I want to use a ruler. Measure this distance. DP. How many cm? How many cm? 4 by 4.3, I think, alright? 4.3. Let's look at the, okay, 4.3, alright. So DP is 4.3 cm. What did the question ask for? The actual distance. So since 1 cm represents 10 kilometers, 4.3 cm will represent 10 times 4.3, right? So what is this? 43 kilometers. Everybody clear so far? So we can get actually, by construction, we can get the actual dimensions. Are you all clear with this particular example? Yes or no? Yes, okay, good. Now, if you want to look at the actual construction, can you look at page 192? They construct for you. But I don't need you to construct, I just need you to remember the steps. Are you okay? Okay, okay, good. Now I'm going into the proper one. Example 13, 14, and 15. These three are the important ones, okay? I'm not saying that the previous ones are not important, you just have to understand the concepts, okay? Alright, now let's look at example 13. All those who are sleeping to wake up. Please do not put the head on the table. Yeah. Example 13. The scale of a building plan is 1 cm to what? 50 meters. Or cm. Okay, sorry, 50 cm. That means 1 cm represents 50 cm on the ground. Okay? Calculate what? The actual length of the bedroom, if it is represented by a length of 9.2 cm on the bed. Okay? So 1 cm the plan that represent an actual distance of 28 meters. Okay. So now I have 28 meters. I want to find on the plan itself how is the thing like. Okay, everybody look at what? I want to tell you this is important. Now, do you agree that the actual one was 1 cm represent 50 cm? Okay, that means this is the plan, this is the actual ground. Now, is it okay if I say 50 cm is represented by 1 cm? It's still okay, I just flip the thing around. Everybody okay? So if 50 cm is represented by 1 cm, okay, now I'll change this to meters because the question gave me in meters, am I right? What is 50 cm in meters? Yes. 0.5 meter is represented by 1 cm. So now how many meters? 28. Very good. So 28 meters is represented by 1 over 0.5 times 28. Always this over this times this. Right, so make sure it's meter, meter, cm, cm. Remember I told you this? Remember the one that I gave you? Since set 1, 4 apples cost $2. Remember this one? How about 7 apples? It will be 2 over 4 times 7, right? 2 over 4 will give you 1. After that it becomes 7. So when you take this over this, it's actually finding 1 meters. Correct? Then you multiply again. Okay, so you should calculate what's this? 50 what? 56 cm, right? So it will be 56 cm on the plan itself. Yes. Yeah, you can use 28 divided by 0.5, but when it comes to area scale, I'm scared you're confused, so you adopt this method will be better. Because for area scale, you square both sides. Okay, I'll teach you later, don't worry. This is linear scale, that means just length only. Understand? Just length only. Are you all okay? Get up? Okay, so it's 56 cm. Okay, now I'm going on to the next part. And I'm going to introduce to you one particular term. Page 194, map skills. All first, are you okay with this? Yes, okay, now let's take a look. Maps are scale drawings of actual land. The linear scale of a map is usually given at the corner of the map. There are several ways to represent the scale of a map. For example, on the map of Singapore, the scale as shown in figure 7.13 may be given. So it's 1:1 million. Can you see? Or they can give you a bar. I think your geography has that, right? They give you a bar there and ask you to measure with string or something like that. Do you all do that? Because I see people don't bring string, right? They take out their shoelace and measure. Because exam, some people pluck out their hair, but the boys' hair cannot work. So, but shoelace not very good because some people use those Velcro shoe or no shoelace one. So I don't know what they do with it, okay? So when they start plucking out their hair, I know that they didn't bring the string. So they will say, let me your shoelace. Then you can see all that untying shoelace, my shoelace. Then they measure the length of the river or whatever. Okay? Now, let's take a look here. There are 2 ways to read the scale. If we use a ruler to measure the length of 0 to 10 kilometers, okay, you'll find that it is 1 cm. Therefore, 1 cm represents 10 kilometers. This is the same as the 1:1 million when the scale is given in this form. It means that we have to use the same units on both sides. We told you 1 meter is to 1 million meter, 1 kilometer is to 1 million kilometer, or 1 cm is to 1 million cm. Do you understand this? Okay, I want you to use your ruler now. You know, I know you understand this one. 1:1 million. That's written at the bottom, right? But I want to use your ruler. Can you measure from 0 to 10? What's the cm? How many cm is that? Because you must also know how to read half cm. Do you get 1 cm? Yes or no? From 0 to 10, do you get 1 cm? Yeah. Yes. That means what it means is this. 1 cm represents 10 kilometers, correct? Because you look at the scale, it's kilometers. Then this is 10, 1, 2, 3 meters, right? Then this is what? 1 plus another 2 0. So cm, I drop the cm, I get this, the equivalent. Everybody clear? So even if I give you the bar, you should be able to do it. Everybody clear? Okay, now. Next is the important one. This one students always forget. ratio form. Now, some maths give it in this form. This is a fraction, right? This is called a representative fraction. And for representative fraction, the numerator, the top, must always be 1. Understand? 1 over something. 1 over something. And short form, this is called the RF. RF means representative fraction. Now, if I say 1 cm represent 20 cm, that means the ratio will be 1 is to 20, am I right? What about the RF, representative fraction? 1 over 20. That is what it means, just that simple. Everybody okay? So, but representative fraction, the numerator must be 1. Get it? Okay, good. So, let's take a look. The scale 1 is to 1 million can also be represented as a representative fraction RF. Okay, so for example, if the RF is 1 over 200, it means the scale is 1 is to 200. When we use RF, the numerator must always be 1. This is what exactly I said. Everybody okay? Alright, now I'm going on to the last 2 examples. Okay, I'll finish all the examples and I'll give you some work to do. Okay, not homework yet, because some work is on the notebook and so on. But for next week, right, because Wednesday is a holiday, I will have 2 days of revision for you for your holiday too. Okay, make sure you do the paper that I've given you and bring it back in the next lesson. And if we have finished going through that, right, I'm going to go through the concepts again for chapter 3, 4, 5, and 8. Understand? Because your factorization, I have to brush it up. Okay, your special identities, you forgot already, most likely. Okay, then your factorization, expansion, okay, and also your solving of quadratic equation, and also plotting of the, the N shape and the U shape graph. Alright, and lastly, the Pythagoras theorem. Alright, yes, I've got a lot of things for you guys. Yeah? Okay. Now let's take a look at the next example. Example 14. Okay, let's take a look at the question. I'm going to go, this one, even my normal tech can do it, so you should be able to. Okay, because I will give you a very clear-cut method. Let's take a look. A, alright, 14, part 1. A map has a scale of 1 cm to 3 kilometers. So you write down, 1 cm represent 3 kilometers. Okay? If the road has a length of 3 cm on the map, calculate the actual length. So 1 cm represent 3 kilometers. 3 cm represent what? 3 times 3. So what is it? 9 kilometers, right? Right now. So an actual ground is 9 kilometers. Agree? Now a very common mistake in exam is students do this. Look at this. This is correct. This is correct. No, you cannot put before. Ladies and gentlemen. If 1 cm is 3 kilometers, all of us back up and go home. No need to have maths already. Because $1 is equal to $3 as well. Okay, so if the chicken rice is $3, just give the auntie $1 there. After that, you cannot box out of Singapore. And end up staying in another country. Do you understand what I'm talking about? Must be careful, okay? Alright, now next. Part 2. If the distance between 2 stadiums is 7.5 kilometers, find the corresponding distance on the map. Okay, now I'm going to do it another way. Now, I can also say 3 kilometers is represented by 1 cm. I'm not changing anything, right? I'm just writing it in the reverse order. Agree? Now, what is the actual length of that stadium? 7.5 kilometers, right? Is it correct? Is represented by, now what is the method that I got you? 1 over 3 times 7.5. So So this will be a 2.5 cm straight away. Everybody clear? Everybody clear? This is how you do it. Okay, now last part. Express the scale of the mat in the form 1/n, where n is an integer. Integer means whole number. Okay? Now, 1 cm represents 3 kilometers. What is this 3 kilometers? How many meters? How many meters? 3,000. How many cm? 30 or 300? Yes, 300,000 cm, right? So actually this is 1 is to 300,000, right? But they want it in a fraction form, right? 1/n. So what is this? 1/300,000. That's all. Or they can ask you for the RF, or representative fraction. It's the same thing. Everybody clear? Everybody clear? Okay, huh? Okay. Now, last part. Okay. Turn to page 195. I'm going to teach you this. This is actually quite easy. Alright? Now, just before the two squares, I want to read the paragraph. Using the scale of a mat, we can also find the actual area of a site from its area on the mat. For example, if the scale of a mat is 1 cm to 2 kilometers, then 1 cm square on the mat represents an actual area of 4 kilometers square. Therefore, the area scale on the mat is this. Now, area scale is different from linear scale. Linear means line. Okay? Let's take a look at 1 cm represents 2 kilometers. Agree? This is the linear scale. This 1 cm on the ground is 2 kilometers on the... No, 1 cm on the map is 2 kilometers on the ground. Okay, now, let's look up. If I square this, I must square this, right? Logical, right? Okay. So what's the meaning of 1 cm square? This is 1 cm times 1 cm. Okay. Remember, if it's a square, it's a times a. So I square this thing is 1 cm times 1 cm. So I will get what? 1 cm square, right? Because cm times cm is cm square. Okay, represent. What's this? 2 kilometer times 2 kilometer. What is this? 4. So this is 4 kilometers square. This is called the area scale. So simple. Just square both sides. Everybody clear? Everybody clear? Okay. Now, next I'm going on to example 15. Okay? I'll leave that over that side. I'll go to example 15 here. If you follow this, right, no problem. Straight away full marks. Understand? Okay? Now let's look at example 15. Okay, let's take a look. A scale of 1 cm to 0.5 kilometers is used for a mat. That means 1 cm represents 0.5 kilometer. This is the first thing that you must write down. Everybody okay? Right, now next. If a plot of land has an area of 8 cm square on the map, calculate its actual area. Now I cannot do it yet because I haven't got the area scale. Okay? So what do I do? Focus. Same thing. I square this side. I square this side. So this one will give me 1 cm square represent 0.5 times 0.5. What's the answer? You don't know, you press calculator, please. Don't use mental sum and get it all wrong. 0.25. You know what? I'm worried that you get it wrong. A lot of people 0.5 times 0.5 is 2.5. What? After that, die already, you understand? You must know. Understand now? Do you agree it's 0.25 kilometers square? Yeah. Okay, so first part. Now it's 8 cm square. If 1 is this, 8 will be what? 0.25 times 8, right? Okay, how much is this? 2 what? 2 kilometers square. Can you see it's very simple? Can you see? Just square then use back the same method. Okay, now next part, part 2. If the actual area of a pond is 50,000 meters square, find its area on the map. This one is a bit more difficult. Okay, I don't want you to use back this one. You must see meter, kilometer, you got to watch out. Okay, all up. 1 cm represents 0.5 kilometer. You read? Huh? 0.5 kilometer is how many meters? 500. I think easier, right? 1 cm represents 500 meters. Alright? Because now the pond is in meters. Meter square, sorry. Okay, so now I'm going to square both sides. I will square this and I will square this, right? Same thing, right? Okay, so what will happen? Tell me. 1 cm square will represent what? How many meters square? 25 plus 40, right? Correct now? Yes or no? 1 cm square represents this, right? Now, do you agree that I have to write this? I have to write it this way, that I can find. Correct now? Now, tell me what's the point? 50,000. So, 50,000 meters square is represented by, okay, what method? Tell me now. 1 over 250,000 times 50,000. So, can I know how many cm square? Don't look at me, my face got no calculator. 0.2 cm square. Are you all clear now? Are you all clear now? Now, let me just warn you. If they give the pond in kilometer square, okay, you will straight away square this one can repeat. Understand? No need to change to meters. I'm making sure that it's convenient for every question. Do you understand? If it's in kilometer square, you have to square straight away. Understand? That means we will use back this one. 0.25 kilometer square is represented by 1 cm square. Actually, it's nothing. We are promoting the same thing. Everybody clear with what I'm saying? Okay, so it depends on the units. I'm teaching you this because I do not want you to be confused and then do the wrong thing. Everybody clear? So if you just use this method, it will be okay. Alright? So this is the whole of this last part. Okay, now I'm going to revise now. All of you turn back to page 186. First, we started off with what? Scale factor. If scale factor is 1, it's the original figure. If it's more than 1, it becomes what? Bigger. If it's less than 1, it becomes smaller. Okay, this is what I said. Okay? Alright, now good. Next. We go on to scale drawings, page 187. Can you see they give you the floor plan? They ask you to find the actual area and so on. Okay? Now, next, we go on to page 189. Can you see we learn how to draw on the graph paper? Okay? Alright, good. Next up, page 191, we learn the construction, right? According to scale. Okay? Next, example 13 on page 193, we know how to calculate lengths on the map and the actual graph. Then after that, example 14, we talk about RF and so on, right? Okay? Last part, we talk about area scale. Understand now? When I have area scale, you got to square both sides. That's all. Everybody clear with what I'm saying? Okay, good. Alright? Okay, let me just take a look now. Okay, I don't think I want to. I will just give you something to try. You can try, you can don't try, it doesn't matter because that one is optional. Okay? Then you got to check it on your own because I'm not going to go through. I'll straight away do the homework together with you so that you don't have to do so hard. Will that be okay? And this homework will be due after WA2. Because I don't want you to be panicking so fast. After WA2, then you can panic. Take your time to do it. Is that okay? Alright. Okay, now. This one, optional. Yes. Now, can we take a look at the optional? one first. Number 4. Using graph paper, draw a scale diagram for each of the following figures shown with their scales labeled. Now, I just want to discuss that a bit. Look at 4A. Is the scale 1:2, right? So, I want to know the final figure. Is it bigger or smaller? Bigger, right? Correct now? Everything times 2, correct now? Okay, if you look at the second one, 1:what? Okay. So, the final one will be bigger or smaller? Smaller. So, to divide everything by 2, right? Do you get what I'm talking about? So, that's how you do it. Okay? Now, next, can you look at number 5? The diagram shows a scale drawing of a field A, B, C, D. It is drawn to a scale of 1 cm to 25 meters. Now, if you want to do this, you got to draw this on foolscap or your notebook. Understand? According to the diagram, and then you construct the next page. Can you look at the question? On the diagram, construct the angle bisector of C, the perpendicular bisector of CD. Now, a treasure is hidden in the field, so on and so forth. You go and do it yourself. Will that be okay? Okay, just try it. It's optional. Clear? Okay, good. What number is it on the content page? 20 what? Okay. Wait, more first. Now, when the diagrams are given, please draw the diagram. Is that clear? When the diagrams are given, please draw the diagram. Yes, okay. No, the optional one, you see, this two has to be done on brown paper. Because you have to enlarge it or minimize it. This one, you have to construct it. So, you either do it on a notebook or on a foolscap paper, whatever. Up to you. It's optional. I'm not going to go through it. Is that clear? Okay. Now, this number 5, I will show you the construction in the next lesson. That will be okay. Not next lesson, after WA2. Because I want you to know what is indicated. Okay? But this one, auto on foolscap. The due date will be after WA2. That means I want it on the 6th of May. That means after the WA2, where's the WA2? Here, right? After WA2, I will go through it and I will go. That means 7, better, right? Even. This one, week. Not week, I will see on Tuesday. Then make it 7. 7. Then I will go through it because I need to go through quite a number of things then. Then I will carry on with the next chapter. Will that be clear? Will that be clear, class? And next week, please bring back the paper that I photostated for you. I'm going to do revision. And I'm going to top up with other questions. Okay? We don't stop the video. Comfortable with that and it's logical.